Today we're solving problem 19 from the Spring Amc 10A from 2021. The area of the region bounded by the graph of x squared plus y squared is 3 times the absolute value of x minus y plus 3 times the absolute value of x plus y can be expressed as m plus n times pi, where m and n are integers. What is m plus n? So this graph has a shape that has an area of m plus n times pi. From this, you can infer that this graph is probably a circle or contains a circle, or it contains a segment that is part of a circle. Well, we can start by first finding the easy cases. When x equals y. I'm just going to use x for this because I like it. 2x squared is equal to, well, that's gone. This is just 3 times the absolute value of 2x. Okay, from this, you get that x is equal to, I'll just write it like that. X is equal to 3 and negative 3, because there's a square and an absolute value here. Okay. Similarly, since x equals y, that means y is also equal to 3, negative 3. So we have really 4 points here. The first one being 3, 3. Second one being negative 3, 3. Third one being negative 3, negative 3. And the last one being negative 3, positive 3, negative 3. That is our first case. Now, I don't have that much room, so I'm just going to erase this. Our second case is finding the intercepts. So let's just say y is equal to 0. When y is equal to 0, that means this equation just becomes x squared. This is equal to 3 times the absolute value of x plus 3 times the absolute value of x again. Okay, x squared is equal to 6 times the absolute value of x. From this, we get that x is equal to positive 6 or negative 6. So 6, negative 6. So from this, we can also infer our third calculation, our third point, like our third case, where x is equal to 0, y is equal to 6 and negative 6, because there's a pattern here at play. Now we can just plot these intercepts. When y is equal to 0, x is equal to 6, 3, 4, 5, 6, and negative 6, 3. And then, similarly, we can also plot when x is equal to 0, this is 6. Yeah, and then we can also plot the 6 here. Now, this gave us a lot of hints to how to draw this. When you plot more points, you begin to realize that the graph is going to look something like this. A straight line going through the 3, and then at this point, and then it's going to curve around here at this intercept, and then it's kind of like 2 pills going together. This drawing isn't that good, but it works. This is our first thing, and then our second is going to look like this. This is the initial drawing, but I assure you these are straight lines. And these are semicircles. That's where the pi came from. Now, we can actually solve this inner square because both these sides are 6 when we count them. So we know that it's going to be 36 plus 4 times the area of each semicircle. There's 2 whole circles, so pi r squared. The radius is 3. 9 pi times 2. This is going to be 36 plus 18 pi. So we have this expressed in the form of m plus n pi. We can find what they want us to. 36 plus 18 will give us our answer of 54. And we are done.